Okay, these are the Module 15 Part 2 notes. This is page 4. We are going to do the same thing, a similar problem. This time we're going to use the classical approach, or the critical value method. We're going to assume that we got a different hospital. Okay. So in example 2, we've got the proportion of patients who visit the emergency room and die within a year is 0.07. We've got a new hospital administrator who's concerned that his ER has a higher proportion. In a random sample of 325 patients who visited the ER a year ago, he finds that 31 have died. We're going to conduct this test at the alpha equal 0.05 level of significance. This time we are going to use the classical approach. So we're going to use z-scores. Okay. So here's a research question. Again, we're talking about a proportion. So is the proportion of ER patients that die within a year higher than the population proportion of 0.07 at the alpha equal 5% level of significance? Okay. We are going to start by checking our central limit theorem. So we ensure that our sample will meet the guidelines for normality. So we know we can use z-scores because we're looking at this as a normal distribution. We gotta make sure we can. We get 21.16, which is greater than 10, so we are okay here. Okay, what's our hypothesis? Well, our null hypothesis is that the proportion is actually that 0.07. This administrator is concerned that his ER has a higher proportion. So our alternative hypothesis right now is that P is greater than that 0.07. So the decision rule, and this is where it gets a little funky with this one, and the picture is going to help. So I am going to draw the picture. Here is my normalish distribution. I'm checking to see if this proportion is higher. Remember, my z is 0. That's my middle. I'm going to have some z-score that cuts off that top 5%, right? Here's my alpha equals 0.05. So to find this criteria score, I'm going to go ahead and go norm.s.inverse of 0.95. Remember that these calculate to the left, so I want the 95% to the left. That leaves the 0.05 to the right. And I should draw that in here too. 1 minus our 0.05 gives us the 0.95 we're using in here. We get a criteria score of 1.48. So let's think about this for a minute. I'm going to calculate a z-score for my data, which I haven't done yet. If it lives up here, right, then I have a problem. That value is way higher than the rest of the population. So that helps me decide which way I got to go here. If my z data is greater than my z criteria score. So now I need my z data. I need my test statistic. So I have got a sample proportion of 31 over 325, which gives me a 0.0954. I can find the standard deviation. Oh, we have what, 0.07, 0.93. Again, these are the population parameters. Always use those when you have them. and I get a standard deviation of 0.0142. So my test statistic, sample proportion minus population proportion all over that standard deviation. I get 0.0954 minus 0.07 all over 0.0142, which gives me a 1.79. And let's think about where that lives. I mean, that's definitely bigger than 1.48. So I've got 1.79 is greater than 1.48. So we are going to reject H naught. State my conclusion. Again, not using complete sentences. I'm okay with the bullet points. We're going to reject H naught. There is sufficient evidence at the alpha equal 0.05 level of significance to suggest, again, nothing is certain, so we never say that definitely something happens, that the rate of death after a visit to this ER is higher than the national average of 0.07. Again, got to state the numbers, got to make sure we got everything in there.